Okay, this question says, if an object with a mass of 5 kilograms is dropped from the height of 14 meters, determine its velocity as it strikes the ground. So we're looking for the final velocity, is basically what we're looking for. We have a rock that's being dropped 14 meters above the surface of the Earth. If you were to look at the previous example, you'd realize that mass actually, although it's given as 5 kilograms, is actually irrelevant to this particular question. Instead, we can use the conservation of energy. Energy 1 equals energy 2, and the fact that before a rock is dropped, it has potential energy due to gravity, and at the bottom it has kinetic energy. Or we can say that PEG is equal to KE. When you do that, you can expand it even further, and you can say, okay, well, mass, gravity, height equals 1/2 mass velocity squared. Since you have mass in both terms, you can cancel it out. And what you're left with is GH equals 1/2 V squared. Well, you are given the height. The height that gave us was 14. You are given gravity, because we're going to assume that it's on Earth. And those are the only two factors that you need in order to solve for the velocity. So we can plug in, we can say 9.8, 14, 1/2 V squared. Multiply both sides by 2. When you do that, you're going to get 2 times 9.8 times 14. That's 274.4. But remember, what that represents V squared. So we have to take the square root of both sides, and what we get is 274.4, take the square root, we get 16.6. Now remember, when you take the square root of something, you're actually taking the plus or the minus. So this could be plus or minus 16 meters per second. Now, since we know that the object is going to be falling, we know that the correct answer is more than likely negative 16.6 meters per second, depending on how you've defined up and down.